Hey everybody, I'm at school today and it's super weird, super empty. There's not many teachers here now, and then of course the classroom's just been empty all day, so it's really weird and I miss y'all. But I'm going to go over the morning work that was attached on the task board for this week. And I had asked in the directions that you solve the questions, just like our normal routine, maybe 2 questions per day. And then there was a haiku quiz that you can check your work on at the end of the week. So if you're watching this video, please be honest and make sure that you've already tried the problems on your own and check them in the haiku quiz, and then you can just skip through this video if you need to and just look at the questions that you might have missed on the haiku quiz, or you might have guessed and gotten it correct, but you maybe weren't sure why. So remember, this isn't for a grade. This video isn't for a grade, and it's just helping you to be honest. There's no point in watching the video and then taking the quiz, because that's not going to help you grow or learn, and you know that, okay? So number 1 says, what is the sum of 2 2/5 plus 3 3/4? And if you think back to when we were adding and subtracting fractions, we used the 4 square method. So in the first block, I'm just going to rewrite the problem. Okay, and then in my second block, I just want to make sure I have the numbers right. In my second block is where I'm going to put my M, and that stands for multiples. I'm trying to find a common denominator, the bottom part of the fraction. And I want the smallest possible denominator that they have in common to use for the third block. So if I list the multiples of 5 over here, and then I list the multiples of 4 over here, remember that just means counting by that number. So counting by 5s, 5, 10, 15, 20, and then counting by 4s, 4, 8, 12, 16, 20. I see that 20 is a common denominator that those numbers share. So here in the third block, I'm going to rewrite my fractions, but my denominators are now going to be 20 instead. Okay, be careful. I feel like in class, the thing that maybe some of you might have missed, maybe you got everything correct except for this one little part and it messed up the whole answer. Whatever I did to get from 5 as my denominator to 20 as my denominator, I have to do the same thing to the numerators. So to get from 5 to 20, I multiplied by 4. And that means I have to multiply my numerator by 4 as well. So 2 times 4 is 8. Same thing over here. If I multiplied my denominator by 5 to get 20, I'm going to multiply the numerator by the same thing. So my numerator here is going to be 15. I'm trying to make that visible, sorry. I've got my camera propped up on a pencil bag, or a pencil pouch that was here. Okay, and then I add my whole numbers. 2 plus 3 is 5. And then I add my numerators. 8 plus 15 is 23, and my denominator stays the same. So I have 5 and 23/20, but I see that this is an improper fraction. So I know that 20/20 would be an extra whole piece. So now I have 6. And if I used 20 out of 23, I have 3/20 left over. So my final answer should be 6 3/20. Okay, number 2 for Monday. What is the quotient if 160 29/100 is the dividend? That's the one on the inside. And 5 85/100 is the divisor. Okay, so when we've divided with decimals, of course, we have to have a happy whole number divisor, mamma mia. So I don't have a whole number. In order to have a whole number, I'm going to multiply by 100, or I'm going to move the decimal 2 places to the right. But don't forget the little jealous pepperoni decimal. I could make it red. That might be easier. A jealous pepperoni decimal. If this decimal gets to move 2 places to the right, this decimal also moves 2 places to the right. Or multiply by 100. So I end up with 2 whole numbers. Remember, it's okay if there's a decimal in your dividend, you just bring it straight up. But I have to have a happy whole number divisor, okay? So 585 goes into, it's not going to go into 1 or 16 or 160. But I could pull out groups of 585 from 1,602. So I'm thinking, okay, even if I round to 500, 5, 10, 1,500, 2,000 or 2,000 is going to be, it's going to be too big. So I'm thinking it's probably only going to go maybe 2 times or maybe 3 times. But I can multiply to see which one it is, okay? 2 times 5 is 10, 2 times 8 is 16, 17, 11. Okay, 3 times 5 is 15, 8 times 3 is 24, plus 1, 25, 5, 10, 15, 16, 17. So 3 times is just a little bit too big. Okay, so 585 times 2 equals 1,170. And then I'm going to subtract those amounts. I've not gotten to this place yet, so I'm kind of ignoring that 9 for now. And then I'm going to subtract. So 2 minus 0 is 2. 0 minus 7, I have to borrow. This becomes a 5. This becomes a 10. 10 minus 7 is 3, 4, and then 0. Then I'm going to bring down my 9. Okay, I know that 585 times 10, I would just add a 0, so it would be 5,850. So I know it's not 10. I think I'm going to try 8 and see what that equals. Okay, 5 times 8, 40, 64. Just a little bit too big. I know that there's only about 300 difference, so I know that 7 times will work. Okay, and then if I multiply, 7 times 5 is 35. 7 times 8 is 56, 57, 58, 59. 7 times 5 is 35, plus 5 is 40. And then again, I'm going to subtract. And I have 234 left over. Now on the quiz, I didn't let you put just a remainder. I wanted you to practice really dividing with decimals and trying to make the number balance out and not have a remainder. So remember that we can add a decimal and bring that decimal straight up, and I can add a 0 and it doesn't actually change the amount. I'm not changing what number I'm dividing with. So I'm going to bring this down. And I think I'm going to try 585 times 4. 4 times 5, let's see, 32, 34. Perfect. Perfect. So 585 times 4 is 2,340. And then I have no remainder left. Sorry, I know you can't see. There you go. I have no remainder left. So my answer is 27 4/10. For Tuesday, number 1, in art class, there are 6 groups of students. There are 4 students in each group. So that tells me that there are 24, I'm just going to put kids. It's a little shorter. The students equally share 30 pounds of clay. How much clay does each student receive? Okay, they're not splitting people. I know sometimes it's tempting, but we're not splitting people, we're splitting the Play-Doh. If there's 30 pounds of Play-Doh, I think it was Play-Doh, yeah, or clay, I'm sorry. If there's 30 pounds of clay, there's 24 kids. I know that each student can at least get a whole pound of clay. So if you look at your answer choices, really, you could eliminate C and D because both of those are saying that the kids are going to get less than 1 pound of clay. Plus, C is trying to split the kids, those poor children. So I know it's going to be A or B. And I can kind of take a guess just based on, 7 pounds versus 1 pound each. But if I'm splitting clay, I'm taking 30 pounds, I'm dividing it by 24. Remember that fraction bar equals division. And then I can simplify. I can divide both numerator and denominator by 6. And then I would have 5/4. And then 4/4 is a whole, and then 1/4 left over. So that's why the answer was B, or 1 1/4 for Tuesday number 1. Okay, Tuesday number 2 just says evaluate the expression. Okay, I'm gonna try to make something, my phone is doing something weird and I'm so afraid it's gonna fall. Go away, okay. I'm seriously afraid it's gonna fall. Okay, so far so good. So remember to use PEMDAS when I'm solving an expression like this. P stands for parentheses, and I can do both of those at the same level or same time. 7 plus 3 is 10. So I'm finished with this one, and then I bring everything else down except for this parentheses. 9 divided by 3 is 3. Okay, so PE stands for exponents. I don't have any. MD, I'm going to multiply or divide, whichever comes first, and in this case, I only have multiplication. 10 times 3 is 30. Bring down -3, and then my last step, 30 minus 3 is 27. I love PEMDAS, and I know some of you do too. I don't know why. It's just really fun to do. Okay, Wednesday number 1. Let's see. Okay, Wednesday number 1. Amber has 20 ribbons that are each 1 yard long. She needs to cut the ribbons so that there are 60 pieces of equal length. What will be the length of each of the 60 pieces? She has 20 ribbons and they're each 1 yard. So basically she has 20 yards of ribbon. And then she's gonna cut those into 60 pieces. I know that if I only have 20 yards and I'm cutting it into 60 pieces, each piece is not gonna be a whole entire yard long, because that would take 60 yards. So if you had an answer like 60 divided by 20, which would end up being 6 divided by 2, or that would equal 3, each piece is not gonna be 3 yards long when there's 60 pieces, because 60 times 3 would be 180 yards, and she doesn't have that much, okay? So I have 20 yards, I'm dividing it by 60 pieces. I'm splitting it equally, okay? Since I have zeros, I can just take those off, and then I can simplify. 2 divided by 2 and 6 divided by 2 would equal 1/3. So each piece is gonna be 1/3 yard long. Okay, number 2 for Wednesday is another fraction. I think we're adding fractions again. So I'm going to use the 4 square method again. Well, this is not as smooth as I thought it would be, but it's okay. Okay, there we go, that kind of works. Okay, Mark walked 4 2/5 miles to the park, and then 6/7 miles to the store. How far did he walk in all? So I'm going to add those 2 fractions. And again, I would use my M. I'm trying to find a common denominator. I need the bottom numbers to match in order to add or subtract, not to multiply or divide, but in order to add or subtract, I do. So I could list the multiples of 5 and the multiples of 7, but also remember that you can just multiply the denominators to find a common denominator. And that would end up being our smallest answer anyway. So I'm going to rewrite the problem. I know that 5 times 7 is 35, so my new denominator is 35. Okay, whatever I do to the bottom, which was 5 times 7, I have to do that same thing to the numerator. So 2 times 7 is 14. Please don't forget that step. I know it's easy to forget and just bring that 2 down, but it's not fair. If I change the bottom, if I multiply that denominator by 7, well, by golly, I have to multiply the numerator by 7 because otherwise it's not fair, okay? So same thing, 7 times 5 equals 35. So 6 times 5 is 30. Okay, and then I can add 4 plus nothing is 4. 30 plus 14 is 44, and then my denominator is 35. But since I have an improper fraction where the numerator is larger than the denominator, I know that 35 35ths would equal another whole. Okay, and then from 35, if I took out 35, there should be 9 left over. Okay, so I just counted from 35 to 44. So my answer is 5 and 9/35 for Wednesday number 2. Okay, Thursday number 1 is another PEMDAS, which I'm excited about because I love them. Okay. Okay, I want to make sure I have the problem written down correctly. So again, I'm going to start with P or PEMDAS, or P or parentheses. And remember that brackets and braces are also in that same category. So I have parentheses and I have brackets, but I always work from the inside out. So my innermost parentheses would be 9 minus 5. And I'm actually going to do it a little bit differently this time. So 9 minus 5 is 4. So I'm just going to erase this. Instead of rewriting it, I'm just going to put my 4 here. Okay? So then if it's just one number in the parentheses, I don't need, that was a weird sound, I don't need these parentheses anymore. Okay? So now I'm still thinking PEMDAS P for parentheses. I have brackets now. I have to solve 4 plus 4 times 7. Please remember that in the brackets or in parentheses, you still follow PEMDAS. So I'm still going to multiply before I add because the MD comes before the AS. Okay, so I'm actually going to say 4 times 7 first, which is 28. Okay, now the only part that's left in my brackets is 4 plus 28, which is 32. And then 32 divided by 8 equals 4. Okay? Last one, number 2 Thursday says, Daniel is painting 2 walls that are the same size. I know you miss my beautiful artwork, my intricate, detailed artwork, you know, because I miss drawing it for you. Okay, here's my 2 walls. They're beautiful. Daniel is painting 2 walls that are the same size. He has already painted 3/4 of one wall. Okay, so he's already painted that much of one wall. He's painted 6/12 of the other wall. Of course, I could draw 12 pieces and color in 6, but I also know that 6/12 is equal to 1/2. So I'm just going to say, okay, Daniel painted half of the wall, or of the other wall. How much area does Daniel still have left to paint? I really like this question. In years past, I think, I'm not your class, but sometimes in other classes where I've seen people solve this problem, and even myself at first, it's easy to just take those numbers from the problem and say, okay, I'm going to add or I'm going to subtract. But it's like a multi-step problem because we're not counting what has already been painted. In that case, yes, we could add 3/4 plus 1/2. But be careful because the question says, how much area does Daniel still have left to paint? So on this wall, he still needs to paint 1/4. And on this wall, he still has 1/2 left. So I want to know how much area he still has left to paint all together. So I am adding now, but I'm not adding the original numbers from the problem. Okay, so I'm taking 1/4 plus 1/2. I do want to find that common denominator, but instead of the big M in the 4 square, I could just make the pictures match. And what I mean by that is I want the same size pieces. So 1/2 is really the same as 2/4. Okay, so for this fraction, I have 2/4. And then when I add 1/4 plus 2/4, of course, I get 3/4. Okay, so I hope that helped. I'm going to try to do this every week for your morning work. And again, you only really have to watch or need to watch the parts of the video that you missed. If you made 100, then, I mean, you can watch, of course. You're welcome to, you know, watch this video. But if you maybe just missed 1 or 2 problems and you don't know what you did, or you need help, or you just guessed and got it right, but you're like, I don't know what I was doing, this will be a good way for you to kind of review what you've learned. A lot of stuff that you learn this year, you're going to use either in life, in real life with decimals and money, or you're going to use, you know, in your future school career. So it's always good to keep those skills fresh, okay? Bye.